Hey guys, I'm back with another question from Fourier series, module 2 from September 2020 M3 exam. So before going to solutions, please subscribe to the channel. The question is find the Fourier series of f of x given in the interval 0 to 2. So the interval does not have pi in it. So we have to consider interval is given in terms of L, 0 to L and L to 2L. So L is equal to what? L is equal to 1. So in this case, what is Fourier series formula? Or Fourier series expansion of f of x. So f of x is equal to a0 by 2 plus summation from n is equal to 1 to infinity an cos n pi x by L. Okay. So in case if pi is there in the interval, it is just cos nx. In case pi is not there, in case it is given in terms of L and 2L, this is the formula. Plus summation from n is equal to 1 to infinity bn sin n pi x by L. Okay, so this is the formula and we need to find out a0, an and bn which depend upon f of x. So what is a0? Let a0 is equal to 1 by L 0 to 2L f of x into dx. So this is a0. A0 formula is 1 by L 0 to 2L integration 0 to 2L f of x dx. So 1 by L is what? L is 1 integration from 0 to L. 0 to 2L is split into two intervals. F of x is split into two intervals between 0 to 2L, which is 2. So from 0 to 1 f of x is pi x dx plus from 1 to 2 f of x is pi into 2 minus x or 2 pi minus pi x dx. Okay, so let's evaluate the integral. So what will you get? 1 or 1 by 1 is 1, you don't have to write it. Integration pi x, I'll write pi as it is. Integration x is x square by 2 from 0 to 1 plus integration 2 pi is 2 pi as it is. Integration 1 is x and minus pi as it is. Integration x is x square by 2. This is from 1 to 2. So let's evaluate the integrals. Evaluate the limits. How do you evaluate the limits? Upper limit in place of x minus lower limit in place of x. So pi by 2, 1 square minus 0 square plus, if you substitute 2 here, 2 into 2 pi is 4 pi, right? Minus, if you substitute 2 here, 2 square is 4, 4 by 2 is 2, 2 into pi is 2 pi. Minus, substitute lower limit. So if you substitute 1 here, it is just 2 pi minus, if you substitute 1 here, it is just pi by 2. So if you evaluate this, what will you get? A0 is equal to pi. So we found out A0. A0 is equal to what? A0 is equal to pi. Now next we have to find out AN. Okay. So next is AN. Now we found out A0. Next is AN. AN is what? AN is 1 by L integration from 0 to 2L f of x cos whatever is beside n here, that is cos n pi x by L, right? That is cos n pi x by L is 1. So you don't need to write this into dx. So if you substitute f of x, what will you get here? This is equal to 1 by L is just 1 because L is 1. So integration from 0 to 2L is split into two intervals, 0 to 1 and 1 to 2. So 0 to 1 we have pi x cos n pi x dx plus from 1 to 2 we have 2 pi minus pi x into cos n pi x dx. Okay, how do we evaluate limit? Here we have a polynomial into a trigonometric function u into v. Here also you have polynomial into trigonometric. This is uv. You have to use uv rule. What is uv rule? Integration uv is equal to u into integration v minus u dash into 2 times integration v plus dash dash dash. We just need 2 terms here. Okay. So what will we get? An is equal to pi, I'll keep as it is, x u into integration v, x into integration cos n pi x is sin n pi x by n pi. Whatever the coefficient of x here will come in the denominator. Next what? Minus u dash. U dash is differentiation of x with respect to x, that is 1. And integration of sin n pi x. 2 times integration of cos n pi x is 1 time integration of sin n pi x, which is minus cos n pi x by n pi, and this n pi will become n pi square. Okay, so this is the first term, plus u into v, integration v. U is 2 pi minus pi x as it is. Integration cos n pi x is sin n pi x by n pi. Next, minus u dash. U dash is differentiation of 2 pi minus pi x. 2 pi differentiation is 0, minus pi x differentiation is minus pi. 2 times integration of cos n pi x is 1 time integration of sin n pi x, which is minus cos n pi x by n pi, and this n pi will become n pi square. This is from 0 to 1, okay, and this is from 1 to 2. Now we need to evaluate limits by substituting upper limit in place of x minus lower limit in place of x. So what will you get? Pi, open a big bracket. For upper limit, if you substitute 1 sin n pi by n pi, that is sin n pi by n pi, minus into minus plus cos n pi by n pi square. Okay, this is minus lower limit. If you substitute lower limit, 0 into anything is 0, minus into minus plus cos n pi times 0 is cos 0 by n pi square. This is the first term. Now here, plus if you substitute 2 here, what will you get? This will become 2 pi. 2 pi minus 2 pi is 0. 0 into anything will be 0. Minus into minus plus, plus into minus minus. If you substitute 2 in place of here, you will get pi cos 2n pi by n pi square. Okay. This is for upper limit minus lower limit. For if you substitute 1 here, 2 pi minus pi will be pi sin n pi x will become just n pi by n pi, minus into minus plus, plus into minus minus. Substitute 1 here, pi cos n pi by n pi square. Okay, so you will get 2 terms for each one of this term, and there are 4 terms like this. So what will you get? Sin n pi is 0, cos n pi is minus 1 power n, cos 0 is 1, cos 2n pi is 1, sin n pi is 0, cos n pi is minus 1 power n. So if you evaluate all of these things, what will you get? An is equal to pi into cos n pi is minus 1 power n by n pi square, right? Minus into plus minus 1 by n pi square, plus this is minus this is 1, right? So this will be minus pi by n pi square, pi by n pi square, minus into minus plus minus 1 power pi into minus 1 power n, because there is pi here, pi into 1 minus 1 power n by n pi square. So this will give us an is equal to two pi by n pi square minus 1 power n minus 1. Okay, so an is a term n is in terms of n. Okay, so what we have got? An is equal to 2 pi by n pi square minus 1 power n minus 1. So this is a very common answer for an and bn. You get in terms of minus 1 power n minus 1, and in the denominator you get n pi square. Okay, so let's find bn in the next slide. So next is we need to find bn. So bn is again 1 by L integration from 0 to 2L f of x sin n pi x by L. Okay, so we know L is 1, right? So this is sin n pi x with respect to dx. This is what we get. 1 by L means 1 by 1, that is 1. Integration from 0 to L is split into 2 intervals from 0 to 1 and 1 to 2. So I will get integration from 0 to 1 pi x sin n pi x by 1. So I will not write that. So dx plus integration from 1 to 2 pi into 2 minus x is 2 pi minus pi x sin n pi x dx. This is very similar to finding an. Only instead of cos n pi x here, we have sin n pi x here, and the integration will also is same method. So you have u into v here, and here also you have u into v, and we know integration u into v is integration u into v is u into integration v minus u dash into integration v plus dash dash dash. We only need two terms here. So what will you get? Bn is equal to this pi I will take outside, u into integration b, that is x into integration sin n pi x is minus cos n pi x by n pi, the coefficient of x is in the denominator, minus u dash is differentiation of x is 1, integration of cos n pi x, 2 times integration of sin n pi x is, or 1 time integration of cos n pi x. So 1 time cos n pi x integration is sin n pi x by n pi. This n pi will become n pi square, this minus you have to keep it as it is. Okay, so this is the first term. Plus, this is from 0 to 1. Here, u is 2 pi minus pi x, integration sin n pi x is minus cos n pi x by n pi, right? Minus differentiation of 2 pi minus pi x. Differentiation of 2 pi is 0, differentiation of minus pi x is minus pi. The integration of 2 times integration of sin pi x, or 1 time integration of cos n pi x. Integration of cos n pi x is sin n pi x by n pi. This n pi will become n pi square. This minus you have to keep it as it is. So this is what you will get for second term from 1 to 2. So let's evaluate limit by substituting upper limit in place of x minus lower limit in place of x. So what will you get? Bn is equal to pi into, for upper limit you will get, if you substitute 1 here, minus 1 into cos n pi by n pi, minus plus sin n pi by n pi square. So this is for upper limit, minus for lower limit, 0 into anything will be 0, minus into minus plus sin n pi into 0 is sin 0 by n pi square. Okay, plus here the upper limit is 2. If you have to 2 here, it will be 2 pi minus 2 pi is 0, 0 into anything will be 0, minus into minus plus, plus into minus minus. Substitute 2 here, you will get sin 2n pi by n pi square, minus for lower limit, if you substitute 1 in place of x here, you get 2 pi minus pi is pi. This minus I have to write it here. Cos, if you substitute 1 here, n pi by n pi, minus into minus plus, plus into minus minus. Substitute 1 in place of x, we will get pi sin n pi by n pi square. Okay, so in here cos n pi is minus 1 power n, sin n pi is 0, sin 0 is 0, sin 2n pi is 0, cos n pi is minus 1 power n, sin n pi is 0. Okay, most of the terms are 0. What are the remaining terms? Bn is equal to pi, this is here, we have here, pi into minus 1 power n by n pi. Here this all terms are 0. So this is only one term in the first case. Plus, you will get this is 0. This is only 1. Minus into minus plus, pi minus 1 power n, pi into minus 1 power n by n pi. Okay. So we have pi by n pi common. If you take pi by n pi common, what will you get here? This is equal to Bn is equal to 0 you will get, because minus pi into minus 1 power n by n pi plus pi into minus 1 power n pi n pi. So this will be 0. So Bn is 0. Now in that we have found out a0, an and bn. Let's substitute them in the Fourier series expansion and let's see what we'll get. So if we substitute a0 is equal to pi, what will you get here? F of x is equal to pi by 2 plus integration from 1 to infinity. What is an? An is 2 pi by n pi square minus 1 power n minus 1 into cos n pi x. L is 1. So plus bn is 0. So this all terms will be 0. Okay. So this is the f of x that we get. The f of x is equal to pi x in the interval 0 to 1, pi into 2 minus x in the interval 1 to 2. Expansion, Fourier series expansion is this. Okay. So this might seem a long problem, but the prerequisite is you know how to do integration. You know how to solve integration UV and evaluate limits. If you know that, this is just applying this, remembering this formula and remembering the formulas for a0, which is integration f of x dx. An formula is integration f of x cos n pi x dx, and bn is integration f of x sin n pi x dx. So if you want to learn more about the prerequisites such as integration of UV and evaluating limits, and if you want to practice more questions on Fourier series, We have made an excellent VTU M3 course, video course, that you can check out at the link in the description.